Welcome to LeetCode Solver, and I'm a LeetCode Solver. And today we are going to solve a 14th problem of a 30-day LeetCoding challenge. And the problem is perform string shifts. So basically, we are going to open the problem for the first time, and I'm going to explain my idea and thought regarding the problems and the step-by-step process to solve this coding problem in real interviews. So let's open the problem. Let me read the problem first. You are given a string S containing lowercase English letters and matrix shift, where shift I equals direction and amount. Okay, a direction can be 0 for the left shift and 1 for the right shift. Okay, amount is the amount by which string S is to be shifted. Okay, a left shift by one means remove the first character of S and append it to the end. Okay, yes, makes sense. Similarly, I mean this is a circular shift. Similarly, a right shift by one means remove the last character of S and append it to the beginning. Okay, all right. Return the final string after all operation. Okay, basically initial string is SABC and shift is 0 1. 0 means left shift by 1. So if it is ABC, uh, if string is ABC, then left shift will be BCA, right? Yes. And 1 to 1 means right shift by 2 times. So if we want to uh, move to the right by 2 times, then what will happen? First of all, it will be A, B, C. Next time it will be C, A, B. A, B, C and C, A, B. Okay. Yes. All right. So how, let's see the constraint now. The constraint is S length can be 100. Okay. Nice. S only contains lowercase English letters. Okay. Only lowercase 26 characters. And the shift length will be equals to 1 to 100. Nice. And shift either length like basically 2 because it contains a direction and amount of shift, and amount of shift is 100 up to, and 0 and 1 shift I0 first element which is direction and second element which is amount 100, and total length of amount will be, I mean the array size will be 100. So basically if we think about brute force, then in each case we have to perform this amount of rotation. Like in the worst case scenario, we will be doing 100 times rotation for 100 times 100 queries. So query will be up to 100 times for 100 length. So without actually performing anything, we may think about considering the rotation in some smart way. Like if we think about the actual given array element is a bunch of different index like 0, 1, 2 index, and if we rotate this to the left side, then it will be 1, 2 and 0. Suppose if we want to rotate this to the left, then one times, then it's fine. If we do it 100 times, then what will be the um, difference? Like if we do next times, it will be again um, it will be 2 0 1, and if we again rotate it, it will be 0 1 and 2. So basically if we again rotate it to the left, it will again give us 1 2 and 0. So basically the rotating operation are repeating in a cycle. Like first time it was this, next time it is this, third time it is this. So length of the given array is 3. So after each 3 operations, after each third operation, the values in the given array are same again, and we are performing the same kind of operations again. So instead of performing the operation, we may kind of uh, keeping track of number of times we did left and right shift. We can do this because if the shift is greater than the length of the given array, then it is repeating in a cycle. So we can ignore that repetition easily. So let's think about how we can formulate this. So if we are rotating left shift, suppose we are performing left shift L times, which is same as if we perform left shift total number of times, which is equal to, if it is greater than n, then it will repeat again and again, where n is the length of the given array. Suppose n is length of array or size of string. Here the size of string, so which is 3, and if we perform fourth operation, then we can see that uh, the fourth operation is same as the operation we performed here. So 4 modulus 3, which is equal to 1. So performing 4 times left operation is same as performing 1 times left operation, because we are getting the same thing again and again. So modulus tells us that what is the equivalent amount of left rotation which can be done, and which is smaller than the size of uh, the string, which is L modulus n, where L is the amount of left shift, and if we do modulo operation, then we are getting the amount that we actually need to perform. Okay, all right, this is left shift. And similarly we can perform this amount of left shift, and similarly we can perform r amount of right shift as well. Right is r times, then instead of doing it r times, we can do the same thing, because it will after n times there will be repetition, and we can do this thing. Now if we have a amount of left shift that we can perform and amount of right shift that we can perform, then what is the actual shift that we need to do? So this is what we have to calculate. So If it is a left shift, then every element, like if you see here, 0 is becoming 1, and if it is 2 times, the 0 index is becoming 2, and 1 index is becoming 0, and 2 index is becoming 1. And if it is 3 times, then there is no any changes in the index. So basically index are also moving towards the left side, and we can figure out the what will be the index value after performing the left and right shift operation. So if we move it to the right shift operation, then what will happen? Let's track this as well. 0 1 2 initially these are the index, and if we perform a right shift, then what will happen? Then what happen is that 2 will comes to here, and cyclic 0 and 1. Now what will happen? We are going to the right side, so 1 will come, and 2 will be there, and 0 will be there. Now the value are all the value are same as before, and after this we are getting the same repetition again, which is 2 0 and 1. So if we analyze the right shift operation, we can see that if we perform the right shift operation, then index will be decreases. Like if we do 1 times, then it decreases to 1, and 1 decreases to 0, and 0 decreases to 2, and if we do 2 times, then 2 decreases to 0, 1 decreases to 2, and 0 decreases to 1. So basically, I mean, if 0 decreases to 2, that means 0. If we decrease 0, then it will be -1. I mean, if we decrease in a cycle, then what will happen? It will goes to the cycle again. So 0 decreases to 2. So we are going, if we are going to the right side, then basically you have to go to the cycle of the things, like 0, there is always a infinite cycle, 0 1 2, 0 1 2, 0 1 2, 0 1 and 2, and we are considering 0 1 2 here. Suppose this is 0 1 2, and by drawing this array, I am kind of concluding that this is a cyclic shift. So if we have to move to the right side, then basically we have to decrease down the uh, our index. So the range here will be this if we want to go to the, if we do the right operation. And if we go to the left operation, if we do the left operation, then the original array, this one is the original array, which will be equivalent to this one. It will go to the, it will do the left rotation after performing the left rotation. Okay, all right. Now let's conclude our uh, solution idea, which is left shift is increasing position by L times, and right shift decreasing index position by r times. So therefore overall shift will be equals to left plus right. Basically these are left is decreased value. Left itself is a left modulus n. L is equivalent to that, and r itself is r modulus n, and we can perform n modulus over here. Then overall shift will be this. Now if we think that it can be negative, then we know that we can make it positive, adding the n over here. So if we do this, because n is redundant modulo operation, and we can add n multiple number of times, which is redundant, and whatever the value we get, if we add n, that would be positive. So say for we can add only n times. Now let's go through the solution. Shift dot size, we are iterating over every shift, and let's calculate L and left shift and right shift. Left shift amount, which is initially 0, and right shift amount, which is also initially 0. And if we see that shift of I0 is equals to 0 for the left shift, 1 for the right shift, 0, then we will increase left shift amount by 1, otherwise by not 1 but by shift of I1, otherwise we will increase right shift amount by the same value. Okay, there is a mistake in our formula. Left shift is basically increasing the shift overall, but right shift is decreasing the shift overall, as I explained before. So we will have a minus over here. Now this will be, I mean, the amount I added it. Instead of having left shift and right shift, we can have overall shift. So let's say shift amount, which is initially 0, and shift amount will be increased if we are doing left shift, and shift amount will be decreased. Okay, we can decrease shift amount, but we have to consider that it is not negative. So for that, what we can do, we can simply calculate n first. Let's calculate n, which is equal to s dot size. Make sure that shift amount is non-negative. Shift amount will be equal to shift amount plus n to make it positive if somehow it becomes negative, modulus n. Okay, if shift amount itself is very big, then we can also reduce shift amount over here, modulus n, modulus n. Now it's fine. So shift amount is overall this. Okay, all right. Now we have shift amount. How much array index will be shifted? What is the new configuration of the index that we have calculated? Now we have to apply this to every index. So let's define it somewhere with a vector of size n, which is final index, and we'll go through every index and calculate the new index, which is I plus modulus n, and this new index position value will be final answer. So let's calculate a string meanwhile, formulate a string. So we can say shifted string, which is initially empty, and we can, instead of having this vector, we can simply ignore this vector, and we can just configure while finding the new index. So we can say that shifted string will be equal to initial string, which is s, and it will take the value from the new index. Okay, all right. Now we can return shifted string as a answer. Okay, let's compile. ABC expected CAB. Shift index will be, this will be equals to shift amount plus n. We don't need plus n actually. Shift amount is positive. Okay, all right. Now we can go through the solution again, which is basically we calculate the size of the string, and then after we have a variable to hold the amount of shift we performed, and we have gone through the shift size, every shifts, and we figure out if it is a left shift. This is a left shift operation, left shift, and this is a left shift amount, and this amount is reducible to modulus of n, as I explained before. And we are adding, if it is a left shift, then we are adding to the shift amount, and if it is a right shift, we are deducting from the shift amount. And in every operation we are performing shift plus n to make it positive shift value, even if it is shift value, if it is if it become negative. Okay, now we have a new string which is initially empty without anything, and we loop through the index, and every index are shifted by shift amount. So I uh, is will be shifted by this much amount of value. So new index is this, and this new index, uh, the value in the new index is copied from the original string which have this index, and this will move to the ith position of the new string, shifted string. So we appended this to this. Now, so for the given example, uh, we have this. So if we iterate over the given sample, then we can see the overall idea. Shift is 1 and 2. So initially it is 0, and when it goes here, it finds it is a late shift. So now the amount is 1, and next time when it sees that it is a right shift, and it will go here and try to deduct it. So now it will be 1 minus 2, which is equal to minus 1, and here in this step 30th line, we see that it tries to make the amount positive. So minus 1 plus length is 3, so which is a positive number, so which is 2, and modulus n, so which is basically 2. And now we have 2 shift amount, and shift we iterate over every shift value in the shift vector, and now we will go here, and for every index we are calculating the new one. For 0th index we will calculate 0 plus 2 modulus 2 modulus 3, which is 2 basically, and new value here the shifted string will be formulated as the value in the 2 position, which is C, and C is copied, appended in a shifted string. Now in the next step there is 1, and 1 plus 2 is 3, and 3 modulus 3 is equals to 0, and the value at 0th position is A, so A will be appended in the shifted string. Now in the next step there is a the index will be 2, and 2 plus 2 is 4, and 4 modulus 3 is 1, so 1 will be appended, the value at index 1 will be appended, which is B, and we can append B over here. So the final answer is CAB, which is correct. So let's try to submit the problem. Accepted. Okay, all right. You can see the more details. 0 millisecond and 6.7 megabyte memory. All right. Thank you so much, everyone. I would like to explain the time and space complexity here. The time complexity is, as we can see, we are iterating over the size of the shift array, and over full length of the string. So the complexity is big of n, we can say, which is uh, n is max among size of shift array and size of given string. And what is the space complexity? This is a time complexity. And what is the space complexity? Space complexity space complexity here is we are not using any extra space. We are just using some variables like shift amount, which is only one variable, and yes, we are using shifted string, which is a extra memory, which is of length n. So we have to say that this is big O of n space, where n is the size of, we can say m, because to make confusion, m is size of a given string. Okay, this is our space complexity, and there can be solution. I'm not sure. This is my first idea. There could be solution which have lower space complexity, uh, like solving the problem with the constant space. Is it possible? Well, yes, this is possible, but it will take times, n times of, like, the shifted amount times we have to rotate the string, like performing swap operation. Um, if it is ABC, then I am performing swap operation n times for each uh, shift amount. Now the shift amount can be up to n, so which will cost us complexity of n square. So if we try to optimize the space complexity, then we have to sacrifice time complexity. Okay, all right. Okay, all right. Thank you so much. If you have any other solution in your mind or any other approaches, please feel free to share and comment. Yes, if you want similar videos in future, and if you want to take preparation for the coding interviews, please feel free to like and subscribe to this channel. Hopefully it will help you. And yes, thank you so much everyone. Have a nice day.